Welcome and thanks for joining after lunch. Lunch was nice, and it's always tough to be the speaker after lunch because people have a full stomach and are sort of really relaxed. Thanks also for joining my talk on NuGet Beyond Hello World. That's actually a fun story. When Andre first contacted me to speak at the conference, I was like, okay, these guys expect really deep dive content, maybe something about memory management. Although I said to Andre, I'm not sure memory management is a topic that I would bring to the conference because probably everyone in Russia writes their own profiler every morning. But he was, yeah, fine, just submit that session. So I did that. And a week after, he contacted me again and told me, look, in Russia, people write their own profiler every morning. So that's why it became the NuGet session, which is my second passion. Right, I come from Belgium. We are, I think, for those of you who were in Alex's talk this morning, he mentioned something about the Dutch being the tallest people in the world. I think in Belgium we're second. I live in Antwerp there. We have lots of great beers. During the day I work for JetBrains, and at night I work on my own startup called MyGet, where I do a lot of NuGet stuff, and I try to blog about all those topics as well. So the goal for today, for this talk, is not just doing the hello world of creating a NuGet package, publishing a NuGet package, and so on. I'm going to assume you already know those things and you can create your own package or can find the documentation on the internet to do so. What I do want to do is sort of evolve NuGet into a mature ecosystem. I know 3 years ago someone published a farter NuGet package on NuGet.org, which means if you build an application platform or an application store, it's mature if there's a farter application on there, but still I feel there's a lot of NuGet stuff that is not mature enough yet, and that's what I want to do here. Also want to give you an overview of all the tooling that is available and some nice things you can do with the NuGet client SDKs, for example. So let's dive in. So NuGet, as you may know or may not know, it started back in 2011 and started as a way to make dependency management in .NET easier. I don't think the first version really accomplished that mission, but still it really helped in discovering packages from both Microsoft as well as third parties and so on. Since then, NuGet, do you have a question? Since then, NuGet actually evolved into several things. One of them is a repository on NuGet.org, for example. The stuff that I'm building, MyGet, I think Artifactory has a NuGet repository as well. So NuGet evolved into a repository where people can also distribute and share their own packages in their own company or for clients and so on. Speaking of clients, there are clients and tools from both Microsoft as well as third party. So for example, there's the NuGet executable, command line stuff, Visual Studio, Rider has a NuGet client, Xamarin, there's a third party NuGet client called Packet. All the new .NET exe stuff is also a NuGet client. So I think in terms of maturity in variety of tools that are available in the ecosystem, I think we've come a long way. And over the years, some conventions also popped up, some best practices in creating and publishing your own packages. We've seen those from experience, but we've also seen those conventions pop up from other package management tools that have been around for ages. Like, for example, anyone who wrote Perl back in the days, or maybe still today. I know I had to go to CPAN to download a module there and work with it in Perl, for example. We learned from all these different package management tools, and I think .NET Core and the new CS project tooling is actually the combination of all the learnings that we made from all those things. So the learnings that we took away from that is that every project should be a package. Project references are nice and so on, but ideally every project should be a package. If you look at NPM, for example, everything you do has a package.json in the roots folder, and you actually describe that you are creating a package even though you are maybe just building an application. But everything is a package, has versioning embedded, which is a very important concept, and has a description, metadata, and makes it sort of discoverable to find those projects. You can share those things either on NuGet.org or on your own repository, even a file share if you want. And we sort of learned that dependencies should not be in your source control. You do want to describe what your dependencies are on third-party packages, but you don't want to store all the binaries in source control and update them and so on in source control, because it's just bloat, it takes a long time to restore, and it's not easily maintainable to update and so on. So I think from those conventions and from those learnings, I think we can really mature NuGet even further. And there's a couple of topics that I do want to touch that I think are really important when you go out there and create your own NuGet packages. This is my favorite saying. I think I came up with it, but could be something else. But I think package producers are always responsible for consumers. That means if you do something that breaks your package, that breaks integration with your package or something like that, you are potentially breaking one developer or maybe 100, maybe 1,000 developers' workflow, and people will be mad at you for breaking that workflow and not respecting the fact that things should just work out of the box. And it's really easy with NuGet and package managers to break the world. A good example was in the NPM world, for example. Anyone read that left pad was removed there? So apparently there was a package out there that did left padding, where you could add spaces before a word and so on. And that was depended upon by another really popular UI framework. And all of a sudden left pad was removed, which meant that everyone using that UI framework was broken and could no longer left pad because the module was gone. NPM fixed that after a day, but it was quite the uproar. And I think that day, people who were using that framework and wanted to build it on their CI server and so on really had an issue there, if they didn't have a copy. Other examples in .NET world, there are quite a few as well. For example, when you switched to .NET 4.6.1 and you would install the system.net.htp package, you would all of a sudden find that at runtime, your application would break. It would just throw a random exception somewhere that was not there in earlier versions. And even some public method signatures changed as well. So if you wanted to update, and it was just a minor or patch upgrade, I think, even if you did an update, it could potentially break your code, and a lot of people actually had a broken code base just because they wanted to update to a newer .NET framework version and update that one specific package. So that sort of calls for a number of conventions again. One convention there is packages should never be deleted. I think NuGet is a really good example of that. They don't delete packages unless there's like only 5 downloads or something like that. But if you have a really popular package, they will just refuse to remove it from NuGet unless you bring an army of lawyers to Microsoft. Versioning is another really important thing I find. It's because versioning, if you do it well, if you do semantic versioning, you're actually specifying intent to the consumer of your package. If you say, okay, if I update my major version, and that basically communicates to consumers that you may have breaking changes and that they know what they can expect. If you update the minor version, they know there's an update and something was added, and they know it will not break and things will just work and they will have new stuff there. Targeting, I don't know who was in the .NET Standard talk this morning. Targeting is also a really important thing, I think, because it also specifies what your package supports. If you target .NET Standard 1.3, for example, people know, okay, this package only needs a subset of what the .NET ecosystem has to offer, and the package can be installed in pretty much any target framework that is out there. Other things that I think you should do is publishing both metadata and symbols for your packages. Metadata, a good description, a nice icon, a link to your GitHub repo, things like that, basically telling people where they can find more information about your package or working with the package in their software. Symbols, also really important, so people can consume your package, but also debug into your source code to either give you better bug reports or at least find out why something is not working so people can help themselves there. So versioning. Who is familiar with semantic versioning? Yeah, quite a few people. So typically in the .NET world, you would develop something and you would set the assembly version to 1.0.0.0 and it would be like that forever. I've seen a lot of projects that after 20 years are still on version 1.0.0.0. The idea with semantic versioning is to make the version number meaningful. You have the major, the minor, and the patch parts of the version, and optionally a pre-release as well, where you actually state intent. You know that if the major version is incremented, that your package may break people. It communicates a breaking change or a potential breaking change to consumers of the package. So they know if you go from version 1.0 to 2.0, something may break their code. Same with the minor. You basically communicate if the minor increments, there is a feature added or something changed, and people get more functionality from the package they are consuming. The patch version is just for communicating bug fixes. So if you do semantic versioning properly, your consumers of the package will know if it's just a patch that increments, that is just a bug fix, and they can safely upgrade without having to worry about anything breaking their codes. There's a giant manifesto on semver.org, but yeah, go ahead and read it. I think the key takeaway is that versioning should be, will it break? Did something get added? And did I fix a bug? That's basically semantic versioning in a nutshell. Stating intent also helps people in being specific about the packages they want to consume. So for example, in your packages.config or in your new CS proj file, you can specify the version ranges for your dependencies. You can actually say, okay, I'm using Newtonsoft.json, for example, but I want to lock it to a specific major version number. What you can do is enter one of those ranges and basically specify that you are only interested in everything that is in version 10.0.0 and up, as long as it stays below 11. So that helps. And semantic versioning is actually not hard. If you know you broke something or you made a breaking change, just increment the major version. Now I know there's a lot of really big projects out there with lots of developers and so on, so you don't always really know if you may have a breaking change. And there's a couple of really good tools from Particular, for example, that do an API comparison, where you can basically specify two packages, and they will do a scan where they say, okay, some public types have been removed, for example. This means that there's a difference in the public API surface of this specific package, and you know that you should be incrementing the major version because this is going to break people. It will also scan for changed signatures, maybe new methods, and so on. So based on a report like this, you can decide which version you should be incrementing. There's a couple of other ones. For example, where are my slides? Git version is a tool that you can just run as part of your CI, and Git version will also scan your Git repo and add metadata about your commit and so on to the package, but it will also do semantic versioning based on the structured changes it can find. Right, versioning. Targeting, really important topic, I think. There are so many frameworks out there. There's way more than the ones that I have on the slide here. But you may want to run on .NET Framework, on .NET Core, on Xamarin for iOS, Xamarin for Android, Tizen, Micro Framework. Potentially people are still building something on that. For those two users, maybe Windows Phone. So yeah, there's a big list of frameworks, and actually if you go to the NuGet repo, there's a nice file that shows you all the different frameworks that are available, and don't be scared, it's a long file. There's like a lot of frameworks and a lot of combinations of frameworks and so on. So you don't want to just put your package out there and make sure that people will figure out how it can work. So the thing that I want to mention here is that you have to be specific about what your library is supporting. Are you building something that will only ever work on .NET Core? Then target .NET Core or use the .NET Standard or whatever. Be specific about what you will support and what your library will need, so your users will be happy. So nobody building a Windows Phone application, for example, will be installing a Xamarin client NuGet package that will never be able to install and that they can never be able to use. So you want to be specific there. Multi-targeting is really easy, especially with the new NuGet format or the new CS proj format. I have a nice library here, which is Hello World with a factory and a provider and so on. And what I did was I created a NuGet package out of that, and you can easily do that in the new Visual Studio by just ticking the box and providing some metadata. Now, the nice thing is, if I now build this package or build this solution, what you will see is that the generated package that comes out currently will contain, let's open it, currently will contain just a lib folder, and it's targeted to .NET 4.5. So nothing really special, and this still means that in newer versions of the .NET framework, this library may work. But all the .NET Core users at this moment are left out, because I didn't target to broaden the scope of the packages or the different target frameworks that I want to support. If you want to change the targeting, that's actually really easy. You can do so in your project file, just edit the CSproj, and change the target framework. If you make this .NET 4.6.2, for example, you will be targeting .NET 4.6.2. If you want to target .NET Standards, you can just enter .NET Standards 1.3, for example, and you will be targeting that thing. If for some reason, so .NET Standards sort of solves the fact that, that you are actually targeting the biggest common denominator between all the different target frameworks. But if for some reason you want to really target specific frameworks, you can also do so here. And that's probably a lesser known thing. If you change target framework to target frameworks, you can do things like, for example, .NET 4.5 and .NET 4.6.2, and maybe .NET 40, let's try. If I now compile this package, or build this package, what you will see is that the resulting NuGet package contains libraries that are cross-compiled and multi-targeted against all those different frameworks. So it's really easy to do the targeting, and by it being really easy, I want you to leave this room and create your own packages that really are specific in both versioning and targeting. Right. The .NET Standards, has everyone been to the session this morning on .NET Standards? Maybe in short, yeah, I know a couple of faces were there, but maybe in short, .NET Standard is basically an interface. It's an interface that specifies, okay, if you target this specific version of the .NET Standard, you know these and these libraries or these and these base class library classes and types and so on are going to be available. And the higher you go in the version number, the more that is supported, the more features that are supported in the framework, but the fewer target frameworks you can actually target with the .NET Standard. So if you go to the documentation there, for example, you will see a nice table that clearly outlines, okay, if I target, for example, .NET Standard 1.3, I can work with all these different target frameworks. If I go to a lower version, I get more frameworks. If I go higher up, I lose Windows Phone. That's pretty much it. Right. Metadata and symbols, that's also a really important thing, I think. Metadata and symbols allows people and consumers of your packages to get more information about what you're publishing. So for example, if you go to NuGet.org, typically you will find a nice description about the package. You will find things like contacting the owners. There's the license information. You can download the package. You can see where the package is hosted, for example, on GitHub or Bitbucket. And you're actually pointing people to resources related to whatever you put out there on NuGet.org. They are not only shown in the web UI, but also in Visual Studio or Rider if you are consuming NuGet. You will see this metadata shown, and people can search on this metadata and read what your package is about and basically know what they can expect of it. Metadata is one thing for helping people figure out how they should work with your library. Another thing is publishing symbols. I think publishing symbols is really important because it helps people troubleshoot both their own codes, because they can step into your code and see how it's interacting with what they are building, but also it helps troubleshooting your codes. If they do find a bug, if the consumer of your package does find a bug, they can simply file a more detailed bug report, for example, because they've been able to step through the code and sort of figure out what was wrong in the code there. There's a couple of ways of publishing package symbols. I think there's a session on debugger as well, which will also go deeper on this topic. The main ways are either creating a symbols package, which is basically adding 2 switches to your CSproj file. The problem with that approach is that it requires a symbols server. So you have to upload the package to a server, and that server has to be configured and has to serve all those symbols to whoever wants to consume them. It's really easy to enable as a developer of the package, but as a consumer, it's slightly more difficult to get started with. A really promising new thing, or it has been around for quite a while, is the portable PDB in combination with things like GitLink or SourceLink. The idea there is that you publish the PDBs of your code, of your application or your library, together with your NuGet package, and the PDBs are linked to your Git repo, for example. So people can just step into, and they will download the sources from GitHub immediately and be able to step into your code without having to configure a symbol server. Now, it's promising, and it just works as a consumer. Problem is, as a developer of packages, it's kind of hard to include it because you have to re-index your source codes and make sure that the PDB is indexed and things like that. Plus, a lot of tools like, for example, WinDBG don't yet support it. So they require basically the first approach. So do publish symbols. No, there's two ways of doing it. But I think right now, unless all the different tools out there support portable PDB, I think the classic symbols package is probably the way to go there. Symbols, is it difficult to create those or create symbols packages? It's definitely not difficult. What you have to do is basically edit your CS_proj file and add two switches there. There's one called include symbols, which you can set to true, and that one will ship the PDBs together with your NuGet package. Of course, if you have the PDB, you probably also want to expose the source code in the package, and that's why you also want to say include sources. And if I now build my package, we will see that in my folder here, I have my traditional NuGet package. I get the libraries that people can install. But there's a second package now called symbols.nubcec, which contains the PDBs for my library. And I think I made a typo. It's include source, just to make it easy. Let's try again. So what you now see is that I have PDBs for all the different target frameworks in here, but the source code of my library is also in there. So a symbol server can index the PDBs to point to the sources that I ship in this package. NuGet.org, for example, does that. So it's really easy to do, and it will really help both your users in figuring out how your library works, but also help yourself because you will probably get better bug reports and things like that. All right. Let's dial up the notch a little bit. I hope this was interesting so far. I think not everyone is publishing symbols and so on, and I do think it's really important that people do versioning properly and make the packages as discoverable and usable as possible. Now, one thing that I didn't talk about yet is that NuGet is actually way more than just distributing simple packages. I want to show you that you can actually do way more things with NuGet than you typically do on a day-to-day basis. So NuGet is, first of all, extensible, sort of. The new .NET CLI, for example, you can create your own tools with which you can extend the .NET CLI, and you can add commands to the .NET CLI that people or consumers of your packages can use to work with it. So for example, if you install Entity Framework Core, you get a tool where you can script database migrations and so on. Do you have a question? Okay. Next to that, NuGet is also a protocol. People always look at NuGet as being this big thing in Visual Studio and the command line thing where I can download packages and so on. But actually, NuGet is also an API. And that API allows you to search, read metadata for something, find things that are out there. And there's even client libraries that you can use to consume such an API. There's that, and there's the fact that versioning is also built in. So you both get an API where you can distribute any type of binary with some metadata, and there's versioning included as well, where you can do things like updating and downgrading and figuring out if there's a newer version of something available. Which actually means if you have a plugin system in your application, for example, you could use NuGet to build a plugin system and distribute the plugins to your end users using NuGet as a protocol. But let's start simple by extending the .NET CLI. The .NET CLI is really easy to extend. It's basically building a simple console application and giving it a specific package type. What you get is, in the real world right now, you get, for example, .NET NuGet and .NET EF are both good examples of such a .NET CLI tool where you can basically extend functionality of the .NET CLI and do things like scripting, entity framework, migrations, updates, and so on. The nice thing is, and this third one does not exist yet, but I think it could be nice if that tool would exist. So for example, if I would install the protobuf package and work with protobuf as a serializer in my application, it would be really nice if they would also ship a tool that extends the .NET CLI with a tool named protobuf, for example, which I can use to script my serialization classes and so on. That would be really nice to have. Also, currently, just working with NuGet, I miss these last 3 commands. If after this talk you feel inspired and you want to go out and build your own tool extending the .NET client, I would love to see a tool that checks for outdated packages. I would like to see a tool that can mirror packages from NuGet to a local folder somewhere. And nuke would also be a really nice option, which would just clear my 40 gigabytes of NuGet caches on my system. So please go build them. How do you do it? Basically, what you have to do is create a console application. It has to be named, or at least the assembly name or the application name has to be .NET-whatever you want. And you have to package it with a specific tag in the CSproj file. So you have to specify that the package type is a .NET CLI tool. Other than that, that's pretty much it, and you can install it in any project out there. There's some documentation about the things that you can do, but basically it's just a console application. And I'll give you a quick example of how to do it. So I created a tool called .NET Init. And .NET Init is much like you have NPM init, for example. I create a new library, and what I want to do is quickly set up my NuGet metadata versioning, package title, and things like that. So what I created is a tool called .NET Init. And if I install it into my newly created library and build it, and run a .NET restore, I will now have a new tool available on the .NET CLI where I can do .NET Init. And this tool will basically ask me a couple of questions. It will find that my project file is this specific project file. It will read the project ID, and it will suggest setting the NuGet package ID to some library. So I can do that. Some library, fine with that. Version, let's say 2.0. I can specify the author. Let's put myself in there. And some other metadata, like the description. Copyright, no copyright, all fine. Yes, I'm fine with this. Save. And what will happen is that my tool updates your CSproj file and adds the necessary NuGet package metadata like package ID and so on. I think it's a nice and easy tool, and I actually wonder why it's not the default item that is shipping with the .NET CLI tool. But anyway, how did I build this thing? So I now consume this thing. How did I build this thing? That's actually really easy too. So I mentioned you have to create a console application. There's no SDK or whatever, it's just a simple console application. So you could write this in .NET, but you could eventually also write something in C++ and just create a .exe out of it. What you get is you get your arguments, so everything you pass after the .NET name of your tool, whatever, those arguments will be passed into your console application. And all that you can do in there is basically up to your imagination. If you want to rickroll someone by creating a .NET rickroll tool, you could do so by opening the browser, for example, and playing Never Gonna Give You Up on YouTube or something like that. There's no SDK, which means that for my simple tool here, where I was editing the CSproj file, I also had to create my own CSproj file implementation that exposes the different project elements and so on. So it's basically up to you how to build this. Just a console application with a specific name. And when packaging it, don't forget to specify the package type, which is this one. It has to be a .NET CLI tool, where .NET is with a lowercase n, really important. So that's pretty much it, nothing more to it. Right, NuGet also has a nice client SDK that you can use to do things with. So you can consume NuGet programmatically. Why would you do something like that? Well, a simple example could be creating your own NuGet client or fetching some specific package somewhere and reading package metadata. The client SDK also allows you to download and extract packages. So if you search for a package and you find this metadata, you can also use the client to download and unzip the package basically and consume whatever is in there. You could, for example, create a custom build task that reaches out to NuGet and downloads a package during build, for example. Or maybe another nice example would be distributing your own application or your own application plugins by creating a custom plugin manager that uses NuGet as the transport mechanism. The transport and the versioning basically come for free. It's in the protocol, and all you have to do is use your imagination to build something around that. For example, in ReSharper, the extension manager that you have there, if you install extensions, those are actually hosted on a NuGet feed, and you just install the extensions that are distributed as NuGet packages using a custom client. Chocolatey, another nice tool that allows you to install software on your computer. They use NuGet as a transport mechanism as well. So they basically wrap executables or MSIs inside a NuGet package and use NuGet as a protocol to ship those packages and install them on your machine afterwards. Seek is one of those other nice examples. Seek is a tool that allows you to do centralized logging. So you can basically set up Seek as a tool to search through your log files, simply said. Now, they also have an extensibility model where you can install plugins, and they also do that using NuGet as a protocol. A couple of CMS products out there do the same thing, Orchard, Sitecore, Episerver. So there's lots of people already doing this, and it's not hard to do. How would you consume NuGet programmatically? In the old world of NuGet, there was one library called NuGet.core. Now, NuGet.core has a few issues. Being that it's basically bloatware, it's a little bit bloated. It only communicates with .NET, or with NuGet v2 servers, so not the new v3 protocol. It also leaves a trace on your system by not cleaning up the cache, for example. So yeah, you can use it. It's really easy to consume, but it's probably not the best way going forward, especially since Microsoft is no longer maintaining that package. In the new world, there's a series of packages. So they basically split up this NuGet client SDK in a series of packages, of which I think NuGet.packageManagement is probably the one you want to start with. NuGet.packageManagement is basically the main package that contains some functionality, but also all the different dependencies that are required to communicate with the NuGet server out there. If you want to read more after this talk on this tool, search for the name Dave Glick. He has written a nice blog series about using this package and all the different weird things that are in this package and how you can do certain things. But I'll give you a quick demo in a bit. So the packages, NuGet.packageManagement is the important one because it contains the entry point to using this SDK. And then depending on the functionality you need, you will also have to install a couple of other packages. To work with the protocol, to actually communicate with a server, you either need to install protocol core v2 or v3, or both, depending on what the server supports. You will require NuGet.project management as well. Project management being the ability to store the fact that I've installed this specific version of this package on disk, keeping track of what you installed. NuGet.packaging is the thing that can read and extract the binaries and interact with the binaries and see whatever is in there. NuGet.versioning implements the versioning, of course. And if you want inspiration on how to do certain things, all the things that you can do with a NuGet.exe command line client are in NuGet.commands. So if you want to go out on GitHub and see how, for example, the install command has been built by Microsoft, NuGet.commands contains this thing and can give you some clues on how to do certain things in your own code. But enough slides, let's dive into code. So working with the NuGet client is quite easy. Like I said, you have to install a couple of packages, and let's be very meta and create a client that searches packages and that installs a random package from NuGet.org. So what I need is, of course, a couple of NuGet clients, NuGet package references. I'm still on old style project, I see. So the packages that are installed are pretty much all there is in NuGet, and package management being the main one that I installed there. How do you go about searching packages on NuGet? Well, what you can do is simply query the API and search for packages. How would you go about this? The way the client SDK is structured is that it's built around resource providers. That means to be able to achieve some task, I need to ask the client, can you give me the resource that handles this task? So for example, I want to communicate with a server that is out there. What I'm doing here is adding two providers, namely the V2 and V3 protocol provider so that I can actually communicate with the server. Next thing I need is a package source where I just reach out to the new NuGet.org API. And using this package source, I can create a source repository. The source repository is basically the thing that will go out and communicate with the package source using the protocol providers that we've added earlier. So it's composition, and you're basically building your own client here. Next thing we need is a resource. So I told we want to search. Well, what we can do is ask the repository for a package search resource, and that thing gives us a couple of methods that we can use to search packages on NuGet. So there's a search async, a toJSON, and a toJ token. So nothing really useful apart from the search async. What we can do then is simply call this search async method with our search term, the thing that we want to search for. We can also optionally add some additional search filtering. So for example, in here I said that, okay, I'm also interested in pre-release packages if you search. I can do paging, so let's start at element 0 and end after 10 items. I have to pass in a logger, specific logger to NuGet, which comes with a null logger if you don't want logging. And after that, I can simply call this and loop the different search results that are available. So if I run this thing, what you will see is that it will go out to NuGet and simply list the different packages that match the search term that I wanted to search for in my code here. So really easy to do as long as you know about the fact that you have to set up the communication with the NuGet server in the client and have to ask this source repository for providers that do search, install, and so on. Right, let's now also install a package. So I have a second method that I call here where I say, okay, install this specific package and this specific version and also include dependencies. How do we go about that? Well, same story as before. Again, we set up our providers, so we specify that we want to communicate using the V2 or the V3 protocol with the server. Again, the package source, again, the source repository linking everything together. And then things start to get interesting a little bit. So if I want to install a package, I also need to use the NuGet.projectManagement package. And that one comes with a class called, for example, folder NuGet project, where I say, okay, I will be installing packages, and the project into which I will be installing those packages is a specific folder on my disk. That's basically what we are doing here. I can load some settings, like which feeds, authentication, and things like that from disk. I actually need those. And once I have that, I can start building my resolution context and fetching packages. So stay with me. I have communication with the server, I have a folder project, and I have settings. Next thing we have to do is create a NuGet package manager. And that's basically the thing that will talk to a server and work on a project. So again, composition of things and then making sure that I can do something like installing packages there. I also need a resolution context. That is basically the thing that will scan all the different dependencies of all the packages that I'm trying to install and sort of build the tree of packages that have to be installed afterwards. There's a default one that comes with NuGet. If you're interested in building trees and things like that, you could build your own. Once I have all those things in place, all that's left to do is ask the package manager to install a package, and magic will happen and the package will be downloaded to my system. So let's do that. And as you can see, I enabled the logger this time, and you see the same logs that you would see during a package restore in Visual Studio, except that the package name is not being rendered, but that's not super important. What is important, though, is that right now on my machine, I have a folder in which I installed NuGet.projectManagement using code and all of its dependencies. So they are now on disk, and I can work with them and do whatever I want with that. Right. Now, a good question could be, why would you want to do that? I'll try to cover that in a little bit. Things to remember from this really simple demo are that the client-side SDK is built around resource providers. So everything you want to do, you have to ask the initial classes from NuGet.projectManagement to give you a resource that can, for example, search or list packages. All operations that you do, like installing, updating, deleting, and so on, you have to do against a project. There's a folder-based project, there's a package JSON-based project, or a project JSON-based project even still that you can use in your application as well. The package manager orchestrates how you work with all operations. So the package manager will decide where you will install the packages and so on and work with all those different classes. Right, now why would you do this? Well, what if you want to build an application that has a plugin system and actually build such an application? Be impressed because it's an utterly amazing application. The application is this one. It's called Search Portal, and it's very enterprisey. It gives you a portal where you can start your search. And that portal has plugins in which I can install search engines like Bing, Google, DuckDuckGo, and so on, and that I will be able to select. Now, I just installed this thing on my machine, and there's of course no search engines installed yet. So what I can do is go to my super secure administration website that does not ask for passwords. And that thing will actually list all the different plugins that I can install into my application. So I list all the different plugin or search providers that I have here. So for example, if I want to search using Bing, I can now install the Bing package or the Bing plugin to my application. And on my front page, I can now search using Bing. I can also install DuckDuckGo and maybe Google. And if I now refresh, all of those plugins are installed and I can select the search engine that I want to search with. Really simple type of plugin, I know, but the point is that you can build your own NuGet-based plugin system using something like this. And it's actually quite straightforward to do as well. So the search engines that I built for Google and DuckDuckGo and so on, what are they? They are simple classes that implement an iSearch engine, so I have to come up with some way of calling into the functionality of my plugin. And they can generate a search URI based on a search term. So nothing really complicated, but this is my plugin definition, basically. All those different search engines, I package them by adding a new spec file where I just describe that this is a plugin for my search portal and whatever metadata that I want to add in there. What I also did was upload all those plugins to NuGet, so a private feed which just contains those 3 plugins, and build the application to consume this feed and install the packages from this feed. Right, so how does this work? I have a nice controller, which is the administration controller, that allows me to work with my plugin manager. And the plugin manager is the thing that I built, making this a little bit more nice to work with. So what I do when going to this administration website is simply asking my plugin manager to list all the existing plugins and render it to the UI. I have an install button and I have an uninstall button. So really simple, the plugin manager is where things will happen. So let's look into that one. My plugin manager, just like I did in my previous example, works with all the different NuGet client-side SDKs. So I set up a connection using the V2 and the V3 protocol, depending on what the server supports. I create a default package source that points to a feed out there. I create a repository where I will be storing or working with the packages that I want to install. And I have a specific search portal NuGet project. So I want to work with something where I know which packages have been installed, which packages have been uninstalled, and which folder I want to install this thing in. I'll dive into that one in a little bit because it has a few hidden features that you have to know about. But for example, for listing plugins is actually quite easy. All I do here is check which plugins are already installed by actually calling into my search portal NuGet project type of thing. And then searching on the remote to search for packages that I have not installed yet. So exactly the same code, pretty much like I had in my previous example. Just go out there, search for the packages, and maybe install them into your code. Now, installing, actually the same thing that I did in my previous example as well. I work with my project, I have a resolution context, and I install a specific package with a specific ID. Nothing really special. One thing that is special though here is my search portal NuGet project. So I already told you that you always have to work with a project thingy so that NuGet or the client knows where packages will be installed, which packages have been installed, which versions are currently installed, and things like that. Well, I had to create my own version here. So in my previous example, I just installed packages into a folder and that was it, right? The default folder-based NuGet project, so this folder NuGet project, has no logic to determine which packages are installed. So it's basically a one-off thing. You install the packages and this thing will never give you information about what is installed. So what I do here is basically extend this folder NuGet project because I still want to install my plugins somewhere on disk. But inside of this class, I also store a packages config NuGet project. So basically, whenever I'm installing a plugin, what I'm doing in this class is both downloading the plugins and installing them on disk, but also writing into a packages.config the packages that are currently installed and their versions so that I can search for updates and things like that as well in the future. Right. How much time do I have left? I think some 10 minutes or something. Okay. Let's dive into the server API, because that thing also has a couple of nice hidden features, and I want you to leave this room with a couple of ideas of things that you can be building over the weekend. So NuGet always talks to repository. If you want to install a package, it always has to come from a repository. The repository can be a disk share, either on a network folder or on your local disk, or it could be remote over HTTP or HTTPS. The remote option, HTTP or HTTPS, has two APIs, which is actually a lie, and I'll cover that in a bit, but it has two APIs, namely the V2 API, which is based on OData. Pretty much any NuGet server out there is based on the V2 API and exposes its packages as OData. The V3 API is JSON-based and gives you, or sort of maps to all the different resources that you have in the NuGet client SDK. So for example, if in NuGet client SDK you would get a search resource to search for packages, on the server side there will be a search server or search service that you can consume and find in a V3 protocol metadata document. Right, so the V2 protocol is really easy actually. If you know a little bit about OData, it's simply a URI where you can go to and get an atom feed, XML-based or JSON-based, of all the packages that are on the server. There are three methods that have been added to the V2 protocol, namely search, finding packages, find packages by ID, just to find a specific package by ID and version to do restores, I guess. And a method called getUpdates, which allows you to post the number, the version numbers of the packages you currently have, and the server will give back the newer version number, so you can check for updates. The V3 protocol is a little bit more complex. It's actually some sort of a metadata document. So if you go to this URL, and I'll do that in a little bit, you will find that it exposes a list of resources that you can consume. And that's also how the NuGet client works. The resources that are on there are catalog, registrations, flat container, some templates, statistics. There's a ton of them. I'll actually show them to you. All those resources are gigantic. So this is the list of all the different services that NuGet exposes on the V3 protocol, and there's really a ton of them in there. So that's why I told you that the V3 API is a lie, because it's actually a collection of a lot of APIs. Now, the important ones to work with are the catalog, registrations, and search, and so on. Now, how do you go about finding out how to work with this NuGet protocol document? I'll skip the slides and just show you in the service index document. So every resource in this document has a type. For example, if I want to perform a search, I will need a search query service that I can call and do a search on. If I want to do something like autocompletion in my IDE, I can use the search autocomplete service. If I want to fetch the registrations base URL and build basically the URL to where I can download a package on NuGet, I will require the registrations base URL and so on. I can use all these different resources to do, for example, a search. And if I go to the search query service, for example, what I can do is search. I can add a query string parameter and say that I search for JSON, for example, and I will get back the total number of hits, and then all the metadata and the different versions of the packages that I may want to install. Okay. I'll not go further into the server API, just go through the document and see whatever is in there, but I want to give you an idea of things that you can do with the server API. So when you upload a package to NuGet.org, there's a couple of things that happen. The data is first of all added to a database somewhere so that you can edit it on the website and consult it on the website and see what the metadata is and so on. But the next thing that happens is quite interesting. Every uploaded package is also added into a catalog. This catalog is part of this v3 API, and the catalog is basically an append-only stream of all the different events that happened on NuGet.org. So if I upload a package, the catalog will contain an entry saying that I uploaded this package at this point in time, linking to this binary with all those details. Packages are never deleted from this catalog, which also means that I could go back and forth to any point in time, basically in NuGet's history, by consulting this catalog. The catalog is also used by other services on NuGet. So for example, the search index uses the catalog and just checks the latest items that were added in this catalog, indexes them, and exposes them over search on NuGet.org. Now, since NuGet consults the catalog to look at whatever happens in there, we could potentially also make use of this catalog. And that's what I will be doing in the next demo. So the fact that I can consult this catalog and see whatever is in there means that I can write a program that, for example, echoes the packages that have been added to NuGet in the last 3 hours, for example. So what I can do is use or write my own collector that reads the catalog. And the collector is basically something that extends simple commit collector. And simple commit collector comes from the NuGet client SDK. What is in there? I actually created my own version of this to make it a little bit more readable, but the basic thing that this thing does is it reads from the catalog and basically invokes a method in your class whenever it finds either an update of the package or a delete of a package. So if you want to check NuGet's promise that they don't ever delete packages, you could use the catalog to see if they ever deleted packages. You could do that. What I'm doing here in this collector is basically going over the catalog for the last 3 hours, and I get back a JSON element that gives me package ID, updated, license URL, copyright, and all those things. And what's nice is that if I run this, it will take a little bit of time for the commit collector to see which packages or where it should start reading. But what I see now is all the different packages that have been added to NuGet.org in the latest 3 hours. I can do latest 3 hours, I can do yesterday, I can do last 24 hours. Basically, based on the date, I can take a slice of this catalog and see whatever happened on there. Now, why is this interesting? Well, if you want to create something like this that just scrolls the newest packages on NuGet or tweets those packages, you could do that. But I think it's more interesting to do something like the other collector that I wrote here. So next to my echo collector, I also created a local mirror collector. And what this thing does is it also uses the catalog, but instead of just echoing whatever package has been added, it runs and downloads the package from NuGet and creates a local copy of entire NuGet, basically. So if I would run this one, what would happen is that this, where is it? Local mirror collector. What this thing will do is whenever a package is added, it will calculate or generate the URL to where I can find the binary for this package and download it to disk. So if I would run this one, I would be creating a mirror of NuGet for the last 3 hours. So let's run it. And it will also print whatever it's doing. So mirroring package, mirroring package, mirroring package. And what I will find is that on my disk, on my file system here, I get a mirror directory, and this one will contain all the packages that have been added to NuGet in the last 3 hours. So I can simply read from this append-only data structure and get all that data and do something with it. Create my own mirror, but maybe you want to build a reverse package search where you can, where you download all those packages, index whatever is in that package, and know about all those types. You could create your own search engine where you could search for example, JObject, and it would give you back the package. Do something like that using this data. I'll stop this because I don't want to mirror the entirety of NuGet, but just to give you the idea. The catalog data contains updates and deletes. Updates are both adds and updates. So if a package is overwritten for some reason, it will appear as an update twice in the catalog. So there's no real distinguishing between an add or an update. It's chronological, which means if I run my application again and just keep track of the date or the timestamp where I stopped reading, I can just continue at a later point in time and continue where I left off reading there. Why? Mirroring, indexing, whatever you want to do with the data that is available on NuGet. If you want to build a better search engine, for example, you could do so by consuming this metadata and index it yourself. Packagesearch.azurewebsites.net, for example, is a project that some guy at Microsoft wrote. He basically uses this catalog to build a reverse index of, for example, if I search for JObject, it will give me back that it's part of Newtonsoft.json. So what he does is, whenever a new package appears on NuGet, he downloads it, indexes all the public types, and makes it available in this search engine. Right, there's a couple of other extensibility points, and I'll quickly go over those. There's a credential provider that you can plug in. So if you want to plug in an exotic system where you need two-factor authentication to do a NuGet package restore in Visual Studio, the client lets you do that. You can actually do that. I've seen that there's a spec. It's not really finished yet, but it seems that NuGet is also extending the package download mechanism. So it used to be always based on a folder or an HTTP remote server somewhere. This extensibility point will actually allow you to download the package from anywhere. So if you want to ship a big zip file that contains a lot of packages, you could build your own transport mechanism in there. Right, in conclusion of this talk, I would say go out, create your own packages, follow the conventions, do proper versioning, make sure that you target the correct frameworks, and make sure that people who consume your packages know what to expect when they consume your packages. Publish metadata and symbols so they are easily discoverable and easily debuggable and things like that. And also consider NuGet to not only be a tool that can download packages and install them into Visual Studio, but also look at it as a tool that you can extend. Build tools on the .NET CLI, for example, and as a protocol where you can just fetch and search for packages and install them and build your own plugin manager, for example, based on NuGet. With that, thank you, and I'll be at questions.